Now, I've said throughout this lecture series that we'll see more about classes later because classes have come up in pretty much all of the lectures I've had so far, and it's really just that important of a concept in Python. But we had to build our way up to it. We couldn't just start by talking about classes because it would be incredibly confusing. But as I've mentioned a few times, everything in Python is a class. Every object in Python belongs to a class. And a class is really the definition of a data type. It contains data, that's variables, values, and it contains methods, those are functions, but really functions geared toward operating on the data associated with that class. A single object that belongs to a class is called an instance of that class. And classes provide a namespace, so your code is isolated from the outside complexity of your script. This concept of scope will come back into play with classes. And they also provide a mechanism for code reuse through something called inheritance, which will be the next lecture. So when you create an instance of a class, we've been doing this very often in previous lectures, for example, with the list function, which creates a new list object. And typically, the arguments to the initialization function will provide the data that are stored within this new object. And that's through this special method, the special function called underscore underscore init, or for initialize, underscore underscore. And the underscore underscore here is a very special construct in Python, and it's used for something called magic methods, which are methods that do more than what they say on the tin. They, for example, change how when you call string on an object, that object gets transformed into a string for output, among other things, or they initialize a class. So it's like a part of the Python language in essence. And they're all denoted with this underscore underscore. And so this is so common, people really don't want to say underscore underscore a whole bunch of times. So this method would be called dunder init. Dunder as in double underscore. Just a short way of saying it that kind of rolls off the tongue a bit better, although it is kind of confusing. So when we write our own classes, we need to provide this init function to do initialization. And it'll look like this example. So in this case, we're defining a class, or really like a data type, called person. And we define a function within this called dunder init, which is telling us how to initialize this class. This will take an argument that is by convention called self, and that is the object in question, the instance of the object in question, and any other data that we want to include. So in this case, we are taking variables first name, last name, and year of birth. And then we're setting self, which again is that instance of the class, dot first name equals first name, self.last name equals last name, and self.year of birth equals year of birth. So now we have this instance of a person class, and that person class has values that we've just set, first name, last name, and year of birth. So that's probably a very confusing concept if you haven't seen classes before, but bear with me, we will look at some examples. And so now when we want to initialize a person, we would say person, generally with a capital first letter, just by convention for class names. And then we can specify the data that we want to go into this init function, dunder init. And we can neglect this self argument, that's just a quirk of the syntax, because we're creating a new instance on this line, and we already know what that is. The self variable is that instance we're creating. And so this will be a person with first name George, last name Washington, and year of birth 1732. And so now we have this data type, person, and we can print the first name, which is George, of P, which is our person object. We can print the type of P, which is class main.person. And remember, we've seen before things like if we do type of 1, it's class int. So we're creating a new data structure here. It's now main.person. And if we print this out, we can see that it is a main.person object at some address in memory. Now every method that's a member of a class, with the exception of what's called static methods, which we won't discuss, will have an argument named self. So just get in the habit of writing self when you're working with classes. And that argument refers to the instance of that object that's getting initialized or otherwise acted upon by this method. Now, as I mentioned before, there are special class methods that all start and end with 2 underscores. We call these dunder methods. So there's init, which we've seen to initialize an instance of a class. There's string, which is what's called when you use str on an object to convert it to a string. So this will change how it's displayed to the screen. There's lt and corresponding operators. Lt is what's called when you use the less than operator. And this is also used to compare objects for sorting. It just compares whether one object is less than another, and then it knows which one comes first in the sorting order. We also have methods like add, which is what's used when you use the plus operator. We have del, which is used to deconstruct a class, and this is what's called during garbage collection or when using del. Generally, you don't have to worry about this in Python like you would in other languages like C if you're creating a new data structure where you then have to free memory afterward. In Python, that's not as important. It's just important if you have some other, we'll call it a side effect, where you need to, for example, close out some connection, like a connection to a database or otherwise. But for a lot of things like our person class, we just don't really care about that. We've also briefly mentioned before enter and exit, which are called when you enter and leave a with clause, respectively. So when you saw the with open construct in the IO lecture, that was calling the enter function, dunder enter, when it was initialized, and then at the end of it, it called the dunder exit on that file object. We also have iter, which is used to create an iterator, and you also need next, which gives the next element in an iterator. So we have another example here where we're improving our person class. We're making it a lot more complicated here. So we're importing time because we're going to be looking at years of birth, and we're looking at the current year. So we're looking at essentially people's birthdays as well in this improved example. So we have our class person. We have an initialization function, dunder init. It takes an argument self, which is the instance of this object in question, or the instance that's being initialized. It takes the first name, last name, and year of birth as before, and we're setting the values within this instance to the arguments passed to this method. We're also defining dunder str for how this is represented as a string. So in this case, we're giving the last name, comma, first name, and then born year of birth. Again, with self to refer to the value stored in the current instance. We have lt defined, dunder lt, with self and other, which will be another person object. In this case, doesn't have to be, but in this case we're assuming it is. And this will return whether string.lastName is less than other.lastName. So we're saying the less than operator will act on the last name of the objects, and if last name is less than the other last name, which we'll use alphabetical order as we've seen in a previous lecture since it's a string, then we're considering this instance to be less than the other one, and that will help with sorting. And then we also have a method called approximate age, and this is a sort of naive way of calculating someone's age because it doesn't consider the date within a year, but we're just calculating the current year from the time module, and we are subtracting the year of birth for this person from current year. And so this will give us an approximate age, plus or minus a year, right? And so we're creating a list of person instances here. We're creating a person Lou Reed, 1942, Iggy Pop, 1947, and David Bowie, 1947. We're then calling .sort on this list, and it's going to go in and compare each of these person instances with the others using this LT operator here, this dunder LT method. And then for each of these person instances within this rock stars list, we're going to print out the musician and their approximate age. So go ahead and run this. Now you'll notice that when we print musician, since we've defined dunder str, that's what's printed here. We have our last name, comma, first name, born, year of birth, and that takes the place of that thing we saw earlier with the address in memory, so it can be cleaner for debugging and for printing to the screen. And then we can call the approximate age method. And you'll notice this is exactly what we've been doing with things like list.reverse or string.lower or string.split, right? Those are all methods defined in exactly the same way. And so we're calling approximate age on this instance of musician. So really this is like full circle. This should be really exciting to you. Like we're looking at exactly how all of these other data structures we've been exploring throughout this course, how they all work under the hood. So what's actually going on here? We have this person object and we're creating instances of this. And each of these instances has all of these methods that are defined in the class. So all of this stuff as we've written it. And so it has a bunch of functions. These are what we would call the methods of this class. And then since we've called init on this, it has gone through and set some variables within this class. So we have some data within this class, self.firstname, self.lastname, and self.year of birth. And so this instance of this class, this instance of person, has first name equals Lou, last name equals Reed, year of birth equals 1942. And similarly, we have another instance for Iggy Pop 1947. And these each have a copy of the functions. It's actually not a copy, it's a location in memory, but close enough. You can think of it kind of like a copy. So each of these objects knows about all of these methods that we've defined. And then we've set some additional data in that init function. And you could set data in other functions as well, other methods. And so each of these is kind of like a self-contained bundle data structure. It's a bundle of functions, which we'd call methods, and data. And so in our loop here, we're addressing each of these person instances in turn. So we're going through one by one, and we're saying print out musician, which will give us string of musician, and then musician.approximate age, which will go in and calculate approximate age for this particular self-contained instance of this class. And so it would find the current year and subtract the year of birth of this person. Whoops. Now, the variable self I mentioned, you could name something else entirely, but it's used by convention, and I would recommend just sticking to self whenever you're writing methods for a class. Now, this is probably pretty confusing if you haven't used an object-oriented language before, and so if it is, I'd recommend reading the Python tutorial on classes. This will help a lot with understanding exactly what's going on with a class.